Hey everybody, the purpose of this video is to walk through exercise 9.16.3 in the Collaborative Statistics textbook. You will have already done 9.16.2 above, which is where your state and type 1 and type 2 errors. And if you remember from 9.16.2, your job was to read the claim in each of these A through J. And it said some of these were null hypotheses, some were alternative hypotheses, and your job was to decide which was which. So what we have here, let's just look at a few. Americans work an average of 34 years before retiring. Well, that's saying it's equal to 34 years. So your null hypothesis is just that. You might want to contest that by saying they don't. They might not work 34 years. They might either work more or less, or you're not sure, but you just disagree with that number 34. So the research hypothesis could be any one of those. Your average is not 34 years. It might be greater, it might be less. So type 1 and type 2 errors for that one, you would have had in number 2. In letter A, it says state a consequence of committing a type 1 error. So type 1 error would be that you did a research study and you decided that Americans do not work an average of 34 years. Maybe it's more, maybe it's less, but it's not 34 years. And a consequence of making that kind of an error would be, okay, suppose your claim was that they work more than 34 years before retiring. Okay, you might encourage them to save less each year, because if they're working more per year, they can save less each year and still end up with the same fixed amount of money. Again, if you were wrong and they don't work more than 34 years, you might be, as a consequence, encouraging people to save less money than they should otherwise. So that would be a consequence of that. How about a type 2 error? Type 2 error would be you think they work more than 34 years, you do a research study, and it turns out you think they don't work more than 34 years. You have no reason to believe they work more than 34 years. So you get a large p-value from your study. So therefore, if you quote unquote fail to reject the null, so you say, okay, well, I have no reason not to believe that they work more than 34 years. So if that's the case, then your consequence might be very well exactly the converse of the previous. So if you're thinking they're working an average of 34 years, you might base savings plans on 34 years. Well, that might not be the right thing to do. Maybe you should be basing on 40 years or 30 years or some other value besides 34. So the trick is you would have missed the change in the average lifetime of work before retiring. So there's a consequence there. Let's see. Let me use my I'm going to randomly generate a number from 1 to 10 here. Let's do a random number generator. Let me get out here. Random.org. I want to go ahead and fire up a random from 1 to 10. Let's see what random.org tells me to do. It says do 8. All right, so 8 would be this guy down here. H. Europeans have an average paid vacation each year of 6 weeks. Okay, so there you go. There's a claim. It's saying it's 6 weeks. Now that sounds to me like a null hypothesis. They're telling us it is 6 weeks. It is 6 weeks. The alternative is that it's not. The alternative is that it's not 6 weeks. They have an average paid vacation that is not equal to 6 weeks. That's one potential. You could also say, just like before, it's greater than or less than 6 weeks. Okay, so let's say you commit a type 1 error, which means that's your null hypothesis. The research hypothesis will be Europeans do not have an average paid vacation each year of 6 weeks. It's some other value. Okay, so you believe that. So a type 1 error would be you believe it's not 6 weeks when in fact it is 6 weeks. So that's a problem. That's a problem. You believe it's a value that it actually is not. It should be 6 and you think it's something else. What's a consequence of that? Well, one consequence of that is thinking that these folks are making either more or less money than they actually are. If they're paid for 6 weeks of vacation and they're actually getting more than that, okay, and they're actually getting more than that, then that's a different sorry, I had a brain fart right there. If the null hypothesis is that they have an average paid vacation each year of 6 weeks, and that's the truth, but you conduct a study where it comes back not showing that, you're going to think from the results of your study that they either have more or fewer weeks of vacation than 6, which means you think they either make too much money for vacation or less money for vacation, which might, again, you might cite that study talking about Americans. Maybe Americans need more paid vacation. This is exactly what happens very often in political debates. Well, I hear that Europeans, here's a quote of a study that showed that Europeans have an average paid vacation of more than 6 weeks. It's 8 weeks. Why do we only get 2 and blah, 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 and all that stuff. So, again, it could be an outlier study. It could be completely fine data that's collected, but that data comes back just as an outlier. It's one of the 1 in 20s, so with a 5% chance of a type 1 error. So there's a problem right there. Conversely, if you run the research study, you're trying to see if Europeans have an average paid vacation each year of 6 weeks. You run the study and you say, yeah, I agree with that. Well, maybe you're wrong. Maybe you say they do. In other words, you're agreeing with the null hypothesis, but in fact you shouldn't. That's a type 2 error. That's a false negative. That's a false negative. Let's come up with a consequence for that one. Let's generate one more. It's telling me to do number 6. Number 6 would be F. The average number of cars a person owns in her lifetime is not more than 10. Is not more than 10, which would mean less than or equal to 10. Okay, well that implies an inequality sign. That to me sounds like a research hypothesis, which means the null is either 10 or greater than 10. Your choice on this one. The convention is to use the equal sign. The average number of cars a person owns in her lifetime is 10. Now, the absolute opposite of not more than 10 would be more than 10. So that'd be 11 or 12 or 13. So anyway, there's your 2 hypotheses. H0 is that the average number of cars is more than 10. HA or H1, average number of cars is not more than 10 or less than or equal to 10. Okay, so consequences of committing errors. Let's say you committed type 1, which means you believe this claim in F. You believe the research hypothesis when in fact you shouldn't. You shouldn't. Well, if you're assuming that the average number of cars a person owns in her lifetime is smaller than what it actually is, if you're interested in the transfer fees that go when cars are sold. So suppose, for example, when you change titles and whatnot, you have to pay certain fees. Those fees are set by actuarial studies. So if you're basing the fees on the belief that people actually have fewer cars than they are, you might be charging the wrong amount of money for those actuarial fees. So if you think they're actually swapping cars fewer times than they actually are, your good mathematics and your good probability is based on a bad actual value of data. So it's like doing all the math we do in this class using 50-50 coin flips, when in fact the coin isn't 50-50. You can create a binomial distribution based on a 50-50 coin flip, but if the coin itself is not operating at 50-50, there's no reason to think that your data means anything, even though it looks great. So that would be one consequence of creating a type 1 error that pops into my mind. How about a type 2? Okay, so a type 2 would be you don't believe this. You don't believe this. You actually believe the null hypothesis, what would be the average number of cars a person owns in her lifetime is more than 10. Okay, is more than 10. So now you think people actually own. Excuse me, it's a type 2 error, you're doing a false negative. So what you're doing is you're saying the null hypothesis being the average number of cars a person owns in her lifetime is more than 10, okay? You're giving a false negative, which means you believe that. You believe that hasn't changed, when in actuality it has. Well, I think my financial example still works really well for this one. Because if you think that they're having, if you give a false negative, believe the null hypothesis, if you think that cars are changing hands more than they actually are, you might inadvertently lower that transfer title and make too little money for your organization. Okay, and there are other things besides money at play here. I mean, just estimating the number of cars that are in the fleet, or overestimating or underestimating, not being able to set up the correct number of resources for road repair and things like that, and infrastructure. There's all kinds of reasons that might pop up based on an incorrect statistical assumption or an incorrect statistical estimation. So there's a few to get you started. Hopefully that helped a little bit. And any more, feel free to call the office, shoot an email, and we'll get them figured out. I hope that helped.